So today we are going to start off with the new chapter of pharmaceutical analysis 1, that is non-aqueous type of titration. Non-aqueous type of titration is particularly that type of volumetric analysis which is preferred for the drug substances that are weaker in nature. Say for example, weaker acidic and weaker basic in nature. So these weaker acidic or weaker basic substances that are insoluble in water. So with the help of organic solvent, we are going to increase the solubility of analyte. If the analyte is soluble, then only chemical reaction is possible between titrate and titrate. So in case of non-aqueous type of titration, weaker nature of acid and bases are made soluble with the help of non-aqueous solvent. Switch off your mics, everybody. So contents to be covered up under this chapter is the what are solvents, what is acidimetry, what are alkalimetry titration, and with the help of non-aqueous titration, we are going to perform estimation of two drug substances. That is estimation of sodium benzoate and estimation of ephedrine hydrochloride. Both these drug substances are weaker in nature. So with the help of organic solvent, we are going to increase the solubility of the drug substances, and with the help of standard solution, and most commonly used standard solution in case of non-aqueous type of titration is the perchloric acid. So from the volume of perchloric acid consumed by sodium benzoate and ephedrine hydrochloride, we can be able to find out its concentration. So these are the bits to be covered up under non-aqueous titration. That is what are the solvent, that is what are the non-aqueous type of solvent, that is Aprotic, Protogenic, Protophilic, Amphiprotic. What is acidimetric type of non-aqueous titration, what is alkalimetric type of non-aqueous titration, and estimation of two drugs, that is sodium benzoate and ephedrine hydrochloride. So before moving on towards the main part of non-aqueous titration, let me clear some basic terms related to non-aqueous titration. First term is solvent. What is solvent? Solvent is a substance that dissolves a solute, resulting into a solution, is known as a solvent. So solvent is that will dissolve the solute. Dissolve करते solute ला म्हणजे काय करते? It will convert the analyte into ionic form, that is either cationic or anionic form. After converting the analyte into cationic and anionic form, and by adding the standard solution to the analyte, then only chemical reaction is possible, and endpoint can be detected by the color change indicator. So solvent is a substance that dissolves completely the solute present in it, resulting into the formation of solution. Second basic term related to non-aqueous titration is the acidimetric titration. In acidimetric titration, it is particularly used for the determination of basic drug substance. So since it is used for determination of basic drug substance, we are going to treat that basic drug substance with the help of standard acid, since the chemical reaction occurs between two different species. Say for example, in case of acid base type of titration, acid reacts with the base, formation of salt takes place. So in case of acidimetric type of titration, with the help of standard acid, we can be able to find out the concentration of base. Therefore, it is known as acidimetric type of titration. So in acidimetry, the standard solution uses, it is having a nature that is acidic in nature. So standard with the help of volume consumed by basic substance, that is standard acid, volume of standard acid, we can be able to find out the concentration of the base. So that type of non-aqueous titration is known as acidimetric titration. Second type of non-aqueous titration is the alkalimetric type of titration. It is particularly used for the determination of acidic drug substances. Sorry. So in alkalimetric type of titration, with the help of standard base, we can be able to find out the concentration of acidic substances. It is known as alkalimetric type of titration. So what is solvent? Solvent is a substance that dissolves a solute and it converts the solute into a solution form. What is acidimetric titration? Acidimetric titration is basically used for determining the concentration of basic substances by the volume of standard acid consumed by it. Next is what is alkalimetric titration. It is particularly used for determination of acidic drug substance. We can be able to find out the concentration of acidic drug substances from the volume of standard base consumed by the acidic substances. Next is basic principle behind non-aqueous titration. Non-aqueous titration are those in which titration of weaker acidic or basic substances are carried out with the help of non-aqueous solvent in order to get a sharp endpoint. If we are going to dissolve the weaker acidic or weaker basic substance in water, solubility of weaker acidic or basic substance, it is very slight one. Therefore, it will not get converted into ionic form and complete reaction will not occur. If the reaction is not complete, then endpoint cannot be determined and finally results cannot be drawn. So particularly non-aqueous titration will particularly in non-aqueous titration with the help of non-aqueous solvent, we can be able to increase the solubility of weaker acidic or weaker basic substances. By increasing the solubility, we can be able to convert it into ionic forms. An easy chemical reaction is possible between ionic analyte and standard substance, and endpoint can be easily determined. So in this titration of substances are dissolved in solvents other than water. Many of the organic compounds are poorly water soluble or very weakly reactive in water, and they are titrated with the help of non-aqueous titration. So what is the main purpose of non-aqueous titration? It will improve the solubility of weaker substances or many organic substances with the help of non-aqueous solvent or organic solvent. So what are solvent? The solvents used in non-aqueous solvents titration plays an important role. Generally, the solvent should be non-toxic one. That is, it should not react with the analyte. It should just increase its solubility for its wide use in analysis, and it should be majorly liquid at the time of analysis. Nextly, the organic solvents which are used in non-aqueous titration depends upon their properties such as capability of self-dissociation, dielectric constant, and acid-base character of the solvent. So selection of solvent in non-aqueous type of titration is done on the basis of these parameters, that is self-dissociation, dielectric constant, and acid-base character of the solvent. By considering these parameters, appropriate organic solvent is used in case of non-aqueous solvent. By the use of organic solvent, we can be able to increase the solubility of weaker acidic or weaker basic drugs, and we can be able to easily find out the endpoint of titration. So what are these organic solvent or non-aqueous solvent used in non-aqueous titration? The first one is the protogenic solvent. Second one is the protophilic solvent. Third one is the amphiprotic solvent. And fourth one is the aprotic solvent. So on the basis of its nature, these non-aqueous solvent are categorized into four major classes. That is protogenic, protophilic, amphiprotic, and aprotic. So non-aqueous solvents are categorized into four classes. Mainly non-aqueous titration follows Lowry-Bronsted law. According to Lowry-Bronsted law, acid is a substance which donates the proton and base is a substance which accepts the proton. Depending upon this, the classification of non-aqueous solvent has been done. So let's see one by one. First non-aqueous solvent used in case of non-aqueous titration is the protogenic. The name itself indicates. Genic means producing. It will produce the H plus ion or it will donate the H plus ion. Therefore, it is acidic in nature. Since non-aqueous solvent follows the Lowry-Bronsted theory, according to Lowry-Bronsted theory, acid is a substance which donates the proton. So here the name itself indicates protogenic means proton or H plus producing solvent. So it is basically acidic in nature. So protogenic solvents, they are acidic in nature and they usually donates the proton. Example of protogenic solvents are sulfuric acid, formic acid, propionic acid, and acetic anhydride. So these are the non-aqueous solvents that are protogenic in nature. That is, they are having ability to donate the proton. Therefore, they are known as protogenic one. An example are the acidic substances, that is sulfuric, formic, propionic, and acetic anhydride. Nextly, these solvents have high dielectric constant and ionized because of their strength and ability to donate the proton. Since they easily donate the proton, they are having a high dielectric constant and they can be easily get converted into plus and minus charges, and chemical reaction is easily possible between titrate and titrant, and endpoint can be determined. Second type of non-aqueous solvent is the protophilic solvent. Protophilic, here philic means loving one. They will attract the proton towards itself. That is, they will accept the proton. Therefore, they are basic in nature. So protophilic solvent are basic in character and they react with acid and to form the solvated protons. The protogenic मध्ये जेवढे काही H+ किंवा protons liberate झालेत एक्झॅक्टली प्रोटोफिलिक मध्ये ते accept केले जातील and formation of solvated proton takes place. That is donated acid H proton donated by the acid, it has been accepted by the base and formation of solvated proton takes place. A weakly basic solvent has less tendency than a strongly basic one to accept a proton. It is quite obvious that stronger will easily accept the proton as compared to weaker one. Nextly, a weakly basic solvent has less tendency than a strongly basic, similarly, a weak acid has a less tendency to donate the proton than a strong acid. Similar will be the case with the acid one, weaker. So amphiprotic solvents are the non-aqueous solvent that are having properties of both protogenic as well as philic one. They can either donate as well as accept the proton. Example of protophilic solvent is glacial acetic acid. Fourth classification of non-aqueous solvent is the aprotic solvent. Means it is not having any sort of property, that is it neither donates the proton neither accepts the proton, therefore it is neutral in nature. So aprotic solvents are neutral, that is they are chemically inert, they neither donates or nor accepts the proton. An example of aprotic solvent is benzene and chloroform. They have low dielectric constant, they do not react with either acids or bases and therefore they do not favor any sort of ionization, therefore they are less in use as compared to other solvent used in non-aqueous type of titration. So this type of solvents neither accept or donates the proton. Example of aprotic solvents are benzene, dioxane, chlorobenzene, chloroform, ethyl acetate and कार्बन टेट्राक्लोराइड. तुम्हाला प्रत्येक क्लासचे एक्झाम्पल्स पार्ट असायला पाहिजेत. दॅट इज प्रोटोजेनिकच्या अंडर येतील ऍसिडिक ड्रग सबस्टन्सेस, दॅट इज सल्फ्युरिक ऍसिड, फॉर्मिक ऍसिड, प्रोपिओनिक ऍसिड आणि ऍसिटिक अनहायड्राइड. प्रोटोफिलिकच्या अंडर येतील ऍसिटोन, पिरिडीन अँड लिक्विड अमोनिया. अँफिप्रोटिकच्या अंडर एक्झाम्पल येईल ग्लॅशियल ऍसिटिक ऍसिड. अँड लास्ट वन दॅट इज अप्रोटिकच्या अंडर येईल बेन्झीन, डायऑक्सेन, क्लोरोबेन्झीन, chloroform, ethyl acetate and carbon tetrachloride. So understood the classification of non-aqueous solvent, that is protogenic, protophilic, amphiprotic and aprotic, depending upon the nature of either donation, acceptance, both or nothing. They are categorized into 4 classes. Next point to be covered under non-aqueous titration is the determination of endpoint. Endpoint in any sort of volumetric analysis can be determined with the help of indicator. The name itself indicates, it indicates the completion of reaction between two, that is titrate and titrant, by the color change. Depending upon the nature of analyte, selection of indicator is to be done. In case of non-aqueous titration, determination of endpoint can be done by 2 methods. That is by with the help of indicator and with the help of instrumental method, that is potentiometric method. In case of potentiometric method, we are going to firstly prepare the aqueous solution of analyte whose concentration is to be determined. Nextly, we are going to dip the 2 electrode in which one will act as an indicator electrode and another will act as a reference electrode. After applying the voltage across both the electrodes, a current will flow due to the electrolysis of the analyte. By measuring the current, we can be able to determine the concentration of analyte. So this part comes under potentiometric type of titration that we are going to study in detail in 5th unit. First part तुम्हाला माहिती with the help of physical indicator, that is with the help of color change that occur in contents in conical flask, we can be able to determine the endpoint in case of any sort of volumetric analysis. But in case of non-aqueous type of titration, most commonly used indicator is the crystal violet and methyl red. So determination of endpoint in non-aqueous type of titration can be done by 2 methods. First one is with the help of physical indicator. Second one is with the help of instrumental method, that is potentiometry. So let's see first one. That is the majority of non-aqueous titration is carried out using a fairly limited range of indicator. प्रत्येक टाइप ऑफ टायट्रेशन, मग ते ऍसिड बेस असेल, नॉन एक्वियस असेल, कॉम्प्लेक्स असेल किंवा रेडॉक्स असेल, इंडिकेटर्स हे सिलेक्टेड आहेत किंवा स्पेसिफाईड आहेत. सो इन केस ऑफ नॉन एक्वियस टाइप ऑफ टायट्रेशन, indicator used is crystal violet, and second one is the methyl one. So how crystal violet can be used? It can be used in a concentration by taking firstly 0.5% weight by volume of solution in glacial ethanolic acid. So solvent used for preparing crystal violet is glacial ethanolic acid. Since we are going to perform non-aqueous titration, so जे काही indicators तुम्ही solution बनवणार आहेत ते सुद्धा with the help of organic solvents आपल्याला बनवायचे. So for crystal violet, the organic solvent used is glacial ethanolic acid. Its color changes from violet through blue, followed by green, then to greenish yellow, in reaction in which bases such as pyridine are titrated with perchloric acid. Say for example, if we are going to determine the concentration of pyridine and if we are going to treat it with the standard solution of perchloric acid, most commonly used indicator is the crystal violet. We are going to prepare the solution of crystal violet by using glacial ethanolic acid as a solvent in a concentration of 0.5% weight by volume. So color change towards the endpoint given by crystal violet is from violet to emerald green. So next indicator used in case of non-aqueous type of titration is the methyl red. It is to be used in a concentration of 0.2% weight by volume, and the solvent used is dioxane, and the color change is from yellow to red color. This is the end point of titration. That is formation of red color indicates the end point of titration. That is all of the titrate has been consumed by titrant one. So these are the two indicators. With the help of these two, we can be able to perform the non-aqueous type of titration and easily endpoint can be determined. Last two bits to be covered up under non-aqueous type of titration is the estimation of sodium benzoate and estimation of ephedrine hydrochloride. Both these drugs are weaker in nature. Therefore, we have to use specific organic solvent for converting the weaker drugs into ionic form. So firstly, let's see determination or estimation of sodium benzoate. So first is the principal part. Sodium benzoate, it is having an antibacterial and antifungal properties. That is, it is mainly used in the treatment of infectious disorders. So sodium benzoate, it is also used as a preservative in various pharmaceutical formulations. And sodium benzoate, it is a salt derived from weak acid and a strong base. So its aqueous solution will be alkaline in nature. Alkaline hai, therefore we are going to treat it with the standard solution of acid. So titrant used in case of estimation of sodium benzoate will be the hydrochloric acid. Since the nature of our analyte, it is basic in nature, since it is derived from a weak acid and strong base. Since the nature of analyte, that is sodium benzoate, it is alkaline in nature, we are going to treat it with an acid. So titrant will be an acid, that is hydrochloric acid. The first solution containing sodium benzoate is acid using a standard solution of hydrochloric acid solution in non-aqueous titration. Next is the procedure. Procedure मध्ये काय principle मध्ये कुठला type of titration आहे? It is a non-aqueous type of titration since it is weaker in nature. Nature of sodium benzoate, it is alkaline in nature. Therefore, we are going to treat it with an acid, that is hydrochloric acid. Next is the assay procedure. Assay procedure मध्ये contents in conical flask exact quantity मध्ये असतील. So next assay procedure मध्ये firstly we are going to wash the burette with the help of distilled water. Then we are going to rinse it with little solution of titrant. Titrant used in case of estimation of sodium benzoate is HCl. So firstly, we are going to wash the burette with the help of distilled water. Nextly, we are going to wash it with the standard solution of titrant, that is HCl. Nextly, we are going to fill up the burette up to 50 ml marking with the help of standard solution of HCl. Nextly, we are going to prepare contents in conical flask. So contents in conical flask will be, firstly, we are going to pipette out 10 ml of unknown, that is the solution whose concentration is to be determined, that is sodium benzoate solution, and then clean conical flask. To the conical flask, we are going to add 25 ml of distilled water. Nextly, we are going to add 15 ml of ether. Here, ether acts as a non-aqueous solvent. It will increase out the solubility of weakly basic sodium benzoate. Since it will improve the solubility, easy chemical reaction will occur between sodium benzoate and standard HCl. So organic solvent or non-aqueous solvent used in case of sodium benzoate will be ether 1. Lastly, we are going to add indicator, that is treat through 5 drops of bromophenol blue as an indicator. So this will be the contents in conical flask, that is 10 ml of our analyte whose concentration is to be determined, that is sodium benzoate. Nextly, for maintaining the conditions dilute, we are going to add 25 ml of distilled water. Nextly, for increasing the solubility of sodium benzoate, we are going to add 15 ml of ether. And lastly, we are going to add indicator, that is 3 to 5 drops of bromophenol blue. Now, next point of titrometric analysis is addition of standard solution of HCl from burette dropwise with constant stirring to contents in conical flask. So with shaking the aqueous solution and ethereal layer until a green color persists in the aqueous layer. So until जोपर्यंत की contents in conical flask मधला color हा green coloration येत नाही, तोपर्यंत standard solution HCl burette मधून conical flask मध्ये add करत राहायचं. Conical flask मध्ये असेल sodium benzoate, it will react with the standard solution of HCl. ज्या मोमेंटला contents in conical flask चा coloration हा green येईल, त्या मोमेंटला HCl चा addition stop करायचं. Note down the burette reading or record the volume of HCl consumed by sodium benzoate. From the volume of HCl consumed by sodium benzoate, we can be able to find out the concentration of sodium benzoate. So this is the method used for estimation of sodium benzoate. Indicator used is bromophenol blue, solvent used is ether, titrant used is HCl. It comes under non-aqueous type of titration. We are going to add 1 ml of standard solution of HCl from burette to contents in conical flask containing sodium benzoate until the color changes green. Formation of green coloration indicates endpoint of titration, that is no more sodium benzoate will be present in conical flask to react with the standard solution of HCl. At that point, excess ml of HCl will get react with the bromophenol blue and it will appear green in color. This is the diagrammatic representation of assay procedure. In burette, we are going to fill standard solution of HCl. In conical flask, there will be solution of sodium benzoate. Nextly, we are going to add organic solvent, that is ether, and lastly, bromophenol blue. Initially, at the start point, the color of indicator due to presence of only alkaline sodium benzoate will be violet to blue. But when we are going to add 1 ml of HCl from burette to contents in conical flask, chemical reaction between HCl and sodium benzoate takes place, and that is indicated by the color change of indicator, that is bluish green. ज्या मोमेंटला contents in conical flask चा color असा bluish green येईल, त्या मोमेंटला HCl चा addition stop करायचं. HCl ची reading note down करून sodium benzoate चं concentration find out करायचं. Next is the calculation part. Chemical reaction वरून आपल्याला factor calculate करता येईल. On the basis of factor and molarity, we can be able to find out the concentration of sodium benzoate. This is the formula for calculating out the percent purity for any sort of drug substances. Here, since we are going to determine the estimation of sodium benzoate, percent purity of sodium benzoate will be volume of HCl that is consumed. Volume of HCl च्या जागी इथं burette reading येईल, म्हणजे sodium benzoate नी किती ml of standard HCl consume केलं. So volume of HCl represents the burette reading into factor into 100. Since we are going to perform the assay procedure in percent form, we are going to multiply it with 101. Nextly, here concentration of HCl used in standardization procedure divided by weight of sodium benzoate. Initially sodium benzoate किती घेतलं होतं in conical flask? We have taken 10 ml into molarity, that is M1 ची value किती येईल? That will be the value here. So by putting all the values into percent purity formula, we can be able to find out the concentration of sodium benzoate. So this is the estimation method of sodium benzoate by non-aqueous type of titration. Organic solvent used in case of sodium benzoate is ether. Nextly, indicator is used is bromophenol blue. And standard solution used is HCl. Last point of non-aqueous titration is the estimation of ephedrine hydrochloride. Ephedrine hydrochloride, it is also weaker in nature. So with the help of organic solvent, we will improve firstly the solubility of ephedrine hydrochloride. Then we are going to treat it with a standard substance. So first is the introductory part of ephedrine hydrochloride. Ephedrine hydrochloride is a phenylethylamine found in Ephedra sinica. This is the biological source of ephedrine hydrochloride. It is isolated from Ephedra sinica, and pseudoephedrine, it is an isomer form of ephedrine hydrochloride. It is neither alpha and beta adrenergic agonist that also enhance the release of norepinephrine. Therefore, it has been particularly used in the treatment of asthma, heart failure, rhinitis, urinary incontinence, and for its central nervous system stimulatory effect, that is in the treatment of narcolepsy and depression. So these are the uses pharmacological actions of ephedrine hydrochloride. It is particularly used in the treatment of asthma, heart failure, rhinitis, urinary tract infection, and CNS stimulant. Since it is an it enhances the release of non-ephedrine, it will be used as a stimulant. Next is the assay procedure of ephedrine hydrochloride. Assay procedure मध्ये content firstly, since the nature of ephedrine hydrochloride, it is weaker in nature, we are going to increase its solubility with the help of organic solvent. So organic solvent used is glacial acetic acid. So contents in conical flask will be firstly our analate, that is 500 mg of ephedrine hydrochloride. For dissolving purpose, we are going to use 25 ml of glacial acetic acid. It is used as a non-aqueous solvent. And we are going to add 10 ml of mercuric acetate solution. This is an extra reagent. It will speed up the chemical reaction between titrate and titrant. Nextly, we are going to mix all the contents in the conical flask with the help of stirring, and we are going to titrate the contents in conical flask with an acetous perchloric acid using solution of crystal violet as an indicator until the color changes from blue to green. So this is the method used for estimation of ephedrine hydrochloride. Ephedrine hydrochloride study, we are going to use standard solution as an perchloric acid, which is to be filled into the burette. Contents in conical flask will be 500 mg of ephedrine hydrochloride. For dissolving purpose, solvent used is 25 ml of glacial acetic acid. Extra reagent used is 10 ml of mercuric acetate, and indicator used is crystal violet. We are going to add 1 ml of standard solution of perchloric acid from burette to contents in conical flask containing ephedrine hydrochloride until the color change in contents in conical flask changes from blue to green coloration. Formation of green coloration will indicate the end point of titration, that is no more ephedrine hydrochloride will be present in conical flask to react with standard solution of acetous perchloric acid. That indicates the end point of titration. Next is the calculation. Here factor for ephedrine hydrochloride is each ml of 0.1 molar perchloric acid is equivalent to 0.020 grams of ephedrine hydrochloride. So percent purity formula for ephedrine hydrochloride, it will be volume of perchloric acid consumed by ephedrine hydrochloride, that is burette reading into factor. Factor will be 0.020107. Since we are going to calculate it into percentage form, we are going to multiply it into 100. Nextly, here comes the value of standard solution or concentration of standard solution prepared. We are going to use 0.1 molar perchloric acid as a standard solution. So here the value of N of HClO4 will come 0.1 divided by weight of ephedrine. We have taken 500 mg of ephedrine for assay procedure. So therefore here the value will come 500 into N of HCl. म्हणजे जे काय M1 ची value will आलेली value इथं place करायची. By putting all the values into the formula, we can be able to find out the concentration of ephedrine hydrochloride. So this is the estimation method used for ephedrine hydrochloride. So in short, we will cover the bits covered under non-aqueous titration. That is, what is solvent? Solvent is a substance that will convert the solute into solution form. What is acidimetric titration? Acidic metric titration is particularly used for determination of drug substances that are basic in nature with the help of standard acid. Standard solution is nothing but the solution whose concentration is known to us. Therefore, we are going to treat the unknown concentration of basic substance with the known concentration of acid one, and its concentration is determined. Next is the alkalimetry. It is particularly used for determination of acidic drug substances. We are going to treat the acidic drug substances with a standard base, and concentration of acid can be determined. Nextly, principle of non-aqueous titration. Principle मध्ये it is particularly used for determination of drug substances that are weaker in nature. Weaker drug substance to solubility can be increased with the help of non-aqueous solvent. Nextly, depending upon the nature or property of solvent, the non-aqueous solvent is categorized into 4 basic classes, that is protogenic, philic, amphiprotic, and aprotic. Of this, protogenic will donate the proton, therefore it is acidic in nature. Example is sulfuric acid, formic acid, propionic acid, and acetic anhydride. Second is the protophilic, means proton loving substances असतील किंवा solvent असतील that will accept the proton. Example is the glacial acetic acid. Next is the amphiprotic solvent. Amphiprotic solvent having both the property, either donation as well as acceptance of the proton. Therefore, they are known as amphiprotic solvent. Now, last is the aprotic solvent. Aprotic solvent, it neither donates, neither accepts the proton. Therefore, they are chemically inert one. Example is the benzene, dioxane, chlorobenzene, and so on. Next is the determination of endpoint in case of non-aqueous titration. Endpoint can be determined by indicator method and potentiometric method. Potentiometric method मध्ये with the help of electrodes we can be able to determine the concentration of annulate. In case of indicator method, two indicators, particularly crystal violet and methyl red, are used for determining the endpoint of titration. Nextly, we are going to determine, or we are going to find out the concentration of two drugs by non-aqueous titration, that is sodium benzoate and ephedrine hydrochloride. In case of sodium benzoate, we are going to treat the sodium benzoate with the standard solution of hydrochloric acid. So a reagent used in case of estimation of sodium benzoate will be firstly annulate, that is benzoate. Nextly, we are going to add distilled water for dilution purpose, and organic solvent used is ether, and indicator used is bromophenol blue. We are going to add 1 ml of HCl from burette to contents in conical flask until endpoint has been reached one. After getting the endpoint, we are going to put up the values into the formula. By putting up the values, we can be able to find out the concentration of sodium benzoate. Last is the estimation of ephedrine hydrochloride. In case of ephedrine hydrochloride, we are going to treat the annulate with standard solution of perchloric acid. Indicator used is crystal violet, and color change towards endpoint is from blue to green coloration. So with this, we have completed non-aqueous type of titration.